So today's assignment involves solving radical equations and word problems involving radical equations. And example 1, we're supposed to solve the square root of x plus 5 minus 1 equals 3. So first thing I want to bring to your attention is the characteristics of a radical equation, so you can recognize what they are. So first of all, you see an equal sign, it makes an equation every single time. And since we have a radical expression containing x, this is considered a radical equation. That's its type. All right, so radical equations range in difficulty from this one, which would be pretty basic, into more challenging ones that have multiple radical pieces. There's x's outside and inside the radical. Those are more complicated, so we're going to investigate those through chapter 5-4, those more difficult ones. The ones today are going to be pretty basic. You're going to find this to be not terribly difficult to do. But as we continue on, the difficulty gets more. But the technique kind of remains the same for the most part. So kind of shallow end type problem here, and we'll move into the deeper water here next week a little bit. So square root of x plus 5 minus 1 equals 3. My first priority on a radical equation is to isolate a radical. If there's only one, that's the one to isolate. If there's multiple, then again, it's a little more involved. So isolating simply means to get by itself. So currently, this is a radical, these two things are not. So to isolate this by itself, moving the 1 to the other side is the most efficient way to do that. So the square root of x plus 5 is being left on the left-hand side. When I move the negative 1 across, it becomes a positive 1. 3 plus 1 makes 4. Again, that's our first priority every time. When I isolate that radical, we'll get it by itself. Our next step, I want the radical to disappear. Okay? Now, it's a root. It's a square root, cube root, fourth root, some root. So in this case, it's a square root. The index matters. All right? So if you write the 2 there, it doesn't hurt. It's not necessary. But no, this is a square root. It's not a cube root or a fourth root or something like that. So in order to make a square root disappear, use square. So the square root of x plus 5 squared is going to make x plus 5. Equations have rules, and one of those, the main rule is basically whatever you do to one side, you do to the other side. So if I'm going to square the left-hand side, I've got to square the right-hand side. 4 squared equals 16. Notice I'm squaring. I'm taking to the second power, multiplying by itself. So square root, squared, radical drops. 4 squared makes a new number over here. By getting rid of the radical, looking at the leftover equation, this would be one of your basic, probably first day of Algebra 1 type problems, right? X plus 5 equals 16. We move the 5 to the other side, change the sign, so x equals 11. Okay. Now, this answer is the candidate running for the position of the answer to the problem. This is not the answer to the problem necessarily. Okay? Sometimes, because we square both sides, sometimes we get what's called an extraneous answer. It's an answer that's trying to be the right answer, but it's not really the right answer. Sometimes these equations have no answers whatsoever. So, once we get an answer, x equals a number, we have to verify that actually works in the original problem. So we go back to the original problem as is, before we messed with it, which says the square root of x plus 5, I'm not writing the x by the way, square root of blank plus 5 minus 1 equals 3. I'm going to put a question mark here because we don't know. We just figured out x equals 11 maybe, so I'm going to put 11 in the position of x. So here's where x is, I'm putting 11 in the position of x. So rewrite the problem, replace x with the value you found. If there's more than one x, replace all the x's. And then verify that it's actually true. If it is, fine. If it isn't, it's not the right answer. So, what's 11 plus 5? What's the square root of 16?
4.
What's 4 minus 1?
3.
So that's true, right? Which means that's the right answer. Right? If we did that check and it came out something like 2 equals 6, which happens sometimes, you would strike it out and put an empty set. The empty set looks like this, by the way. It's a 0 with a slash through it. That means there are no answers. This is the set of nothing. Right? It's not a 0, it's a set of nothing. But again, on this problem, the answer works, so all is well.